Hello guys, this is Siddharth here. Today we'll be solving today's LeetCode challenge, that is pseudo-palindromic path in a binary tree. So what we mean here by pseudo-palindrome is that in a given example itself, if I were to consider that, if I were to consider the highlighted path there is in red, then I'll have something like this, but this does not form a palindrome if we were to go by its natural definition. But if I were to rearrange it, and if I were to write it like this, then this does indeed look like a palindrome, right? So what we need to do here is we need to return the count as to of the sequences, that being the paths that we can go down from root to the lead nodes. We need to return the number of paths that will form these pseudo palindrome, right? So let's just first of all talk about the very idea that as to how we'll, consider as to which specific path is a palindromic path. So we get this idea that for a sequence to be a palindrome, we can have actually two specific lengths, then they're being even. So if I were to consider a palindrome, for example, let's take 1 to 1, right? And then if I were to take another example of an even length palindrome, that will be 1, 2 to 1. What I observe here is that I have this digit 2 that occurs only one time, and I have 1 here which forms a pair, occurs twice. All right. And even length palindrome, what I see here is that all the digits, they're being basically two digits, but they are repeating. So 1 and 2 both are forming a pair. They are present in an even number. So what we conclude from that is that if I were to have, okay, if I were to just, consider another odd length palindrome, I can have 1, 2, 3, 2, 1. So even now, I only have one digit that does not have a pair, right? And in even size palindrome, there will never be the case of there being an odd occurring digit per se. So if we were to consider this example, what we can see here is that, of course, we'll be needing to go down every path to come up with the total count of such paths which form a pseudo-palindromic sequence. So what we can do here is we can go down every path from the root node down to every last leaf node, and we can keep a check that in this very path, if there are values which are occurring odd number of times, and there being more than one value that is occurring odd number of times, then that is a big no. We don't want that path, we will not count it. And if there exists a path where there is only one such digit which is occurring odd number of times, then we are completely fine. So taking this very example, we have 2 here, which is occurring only one time. We have 3 here and then another 3. So we are completely fine with having just one single digit which is occurring odd number of times, that being 2. All right. So in this part, the 2, 3, 1, we can see here that I have 2, which is occurring once, I have 3, which is occurring once, and then I have 1, which again is occurring once. So I definitely don't want to count this part and my pseudo-palindromic parts because I have 3 different digits which are occurring odd number of times. I hope you get the idea. So let's start with a given example. So my pointer will most definitely be pointing towards the root in the beginning. And then I will consider this value of the root and I'll mark it as 1. Or in a sense, I will increment it by 1 because later down the line, I will just be incrementing it. I will not be setting it, if that makes sense. So now after going to the left node, first of all, I'll keep a base case that there being left and right child of a node being null. That will be my one of the base cases. So if I were to encounter a leaf node, then of course it will have both of its left and right child as null. So then I need to, you know, look back into my array and need to check if my total odd digit counter is less than or equal to 1. If that's so, then I'm perfectly fine with it. And I'll count my given path and my total result. All right, I hope that makes sense. So what we need to do now is I went to 2, I marked it down as 1. Then we went to its left child, we came across 3. We'll mark it down as 1 again. Then we'll go towards its left child, we'll come across 3 again, and then we'll mark it as 2. All right. So now we come across this condition that it has both of its child as null. So then we can check as to what my odd counter was having. So we need to take in count the odd value so that I don't have to check my array over and over again. So what we can do here is we'll discuss it in brief here, but in code I'll tell you more about it. So while marking down the occurrence in our array itself, I will change my odd occurrence value then itself rather than going through my array again and again. So if my odd occurrence value is 1 or it's 0, then I'm completely fine with it. Sorry for this bad looking 0, but yeah, anyway. So if that's so, then I'm completely fine with it. So if I have my resultant here, then I'll have it as 1. So in the next, while I'll be returning, as soon as I'll be returning, I'll be removing this very 3 from my counter. So then again, it will be going down back to 1. Let me just remove it. Yeah. So it will be back to 1. Then we'll go to its right node. We'll see that we have 1 here. So yeah. In the meantime, I'll also be incrementing my odd counter. So my odd counter right now will become 3 because I have 3 different digits that are occurring odd number of times. So yeah, my odd counter right now will say 3, which is a big no. So yeah, I'll move back again. While returning, I'll remove this value from my array. So yeah, 1 will have 0 again, and then I'll go back to 3. 3 will have 0 again since I'll be returning from here. Then I'll be going back to 2, and then I'll be moving towards its right child, right? I'll not be removing 2 since it is my root value, and of course I have right child existing as well. So while there exists a right child, I will not be removing the value of my present root node. So while going down its right path, I'll come across one, then I'll have one as its counter, and then again I'll go down one more time, and then I'll increment its value to 2. So that will leave me with 2 as its value. All right, so now my odd counter will be 1, and yeah, that satisfies my condition of there being odd occurrences of digits, and that should be of 1 or 0, so I can just increment my total result, and that should give my answer as 2. I hope that makes sense. Now let's jump to code. All right, so for the start, I'll just initialize an array, a global array, and what we'll do here is we'll check if there exists a root. All right, if there does not exist a root, then we'll just return our count. That is our answer. So what we'll do here is, first of all, we need to check my odds, and with that itself, what I'll do here is I'll increment the values in my count array, first of all. So all right, now what I'm doing here is I am in my odd variable incrementing or adding the value 1 as because the very first time that I'll be adding any value, it will be it will have an occurrence of 1, in a sense that for any value to become even, first of all, it has to start with an odd length. I hope that makes sense. So yeah, if I were to increment the value in my count array, and then if that's divisible by 2, then what I need to do here is, all right, so not to confuse the audience so much, this will be giving me either a 0 or a 1. And 0 would mean that the value that I'm considering is present in even number of times, right? But 0 also means false. So if my all of this expression is going to give up 0, then there exists even value. So I don't need to count that. I actually need to subtract my present value because I would have already counted it as my odd value. So what I need to do here is I need to put a -1 in the end and a 1 in the starting. I hope that makes sense to you. So what I need to do here is I need to check if I'm at a leaf node or not. So if my roots left is equal to my roots right, that being said, it means that my left and right child have null values. So yeah, if that's the case, then what I need to do here is I need to check if my odd values, if they are less than or equal to 1. If that's the case, then I need to return my count as 1, as my final result is 1. Otherwise, I can just return it as 0. Else, if that's not the leaf node we're talking about, then what I need to do is I need to consider my left and right childs, and I'll do that recursively. So yeah, and I'll be passing down my number of odds because that wouldn't change per se. So yeah. And yeah, that will be number of odds. After I'm done doing that, I need to, while returning back, I need to remove my current root value from my array as well. What I'll do here is I'll do this, and if that's even after subtracting it, even if still it's divisible by 2, then yeah. So let's think about it for a second. Even after subtracting it, if it's divisible by 2, that means it will give 0. So I need to subtract 1 from my odds, and if it's not giving me a 0, that means it's giving me a 1. Then for 1 in ternary operator, if this were to give me 1 in ternary operator, you go for the first one. So if this were to give me 1, that means it will give me true. Then this will be considered. So yeah, of course, my odds will increment by 1. So let's now run it and let's see if this works. Yeah, it works just fine. But the time and space complexity of this given solution would be time complexity would be order of n, since we'll be iterating through all the nodes one by one, and the space complexity would be the height of our binary tree. Yeah, so like and subscribe if you really like the content and the explanation. If you didn't, then I would love to hear from you as to what I can improve on. And yeah, catch you in the next one.